Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2012 for 2 marks on the psychometry topic. The question is, the room contains 35 kg of dry air and 0.5 kg of water vapor. So my dear students, here they have given the mass of dry air is 35 kg and mass of water vapor is 0.5 kg. So let us write down this given data. Mass of dry air is 35 kg and mass of water vapor is given 0.5 kg. Then after that, the total pressure and temperature of air in the room are. Total pressure means it is the atmospheric pressure, right? This total pressure is atmospheric pressure and temperature of room is nothing but dry bulb temperature. So here atmospheric pressure, which is nothing but total pressure, is given 100 kilopascal and dry bulb temperature is given 25 degrees Celsius for the room respectively. Given that the saturation pressure of water at 25 degrees Celsius is 3.17 kilopascal. So my dear students, at this room temperature, the saturation temperature is 3.17. Therefore, we can say saturation pressure is equal to 3.17 kilopascal. Right. After that, the relative humidity of the air in the room is. Now, my dear students, they are asking relative humidity, and if you look at the options, all the options are given in percentage. So we have to find relative humidity in percentage. So let us solve for this relative humidity. Now, my dear students, we know that relative humidity is nothing but vapor pressure divided by saturation pressure, right? This is the relative humidity in fraction. Now, if I multiply this with 100, then I will get in percentage. Multiplied with 100, then I will get in percentage. So, my dear students, saturation pressure is already given. So, we have to calculate vapor pressure so that we can calculate the relative humidity in percentage. So, to calculate vapor pressure, we have formula for specific humidity. So, let us use this specific humidity formula. So, my dear students, here specific humidity is nothing but mass of vapor divided by mass of dry air, right? Therefore, the specific humidity omega is nothing but mass of vapor divided by mass of dry air is also defined as 0.622 pressure of vapor divided by pressure of atmosphere minus pressure of vapor. This is how the formula is defined, right? Therefore, my dear students, let us put the values. Therefore, this mass of vapor is given 0.5, mass of air is given 35, which is equal to 0.622 into pressure of vapor is unknown. Total pressure is given 100 kilopascal minus pressure of vapor is unknown. So my dear students, in this total equation, only vapor pressure is unknown. Now here it is a part of aptitude. Here solve this equation. Here I am not going to solve this equation directly. I will write here answer because this is simple aptitude only. You can do this aptitude, and if you are not able to solve such type of aptitude, then it is a big problem for you. You have to practice more and you have to improve yourself for the competition, right? Therefore, vapor pressure is equal to 2.238 kilopascal. This will be vapor pressure. Now, if I put this vapor pressure in the relative humidity formula, that is phi formula, then phi is nothing but vapor pressure divided by saturation pressure. And if I want to find in percentage, then I have to multiply with 100. Therefore, is equal to vapor pressure is 2.238 divided by saturation pressure is given 3.17 into 100. This answer will be in percentage. And if I find in percentage, then I will get 70.6%. The answer will be 70.6%. And now look at the options. The nearest choice is option D. Therefore, as the nearest choice is 71%, therefore this can be approximated as 71% and your answer is option D. Thank you dear students. In next lecture we will see one more numerical on this topic.